what's kind of important about this first example that we haven't had to do yet is we can't complete the square if there's a coefficient in front of x squared and y squared other than 1. So the very first step will be, let's actually divide that 2 out from everything to get x squared plus y squared plus 2x minus 6y minus 3 equals 0. And then you can kind of proceed exactly as we did the other day. So we're going to group the x's, group the y's. Anything without x or y, move to the other side. So go ahead and do that first. Then with my group of x's, I'm going to complete the square by taking 2, dividing it by 2, and squaring it. So 2 over 2 is 1, squared is 1. Do the same thing with the y's. -6 divided by 2 is -3, squared is a 9. And make sure to keep this balanced. You also remember to add 1 and 9 to the other side. So now this group, after completing the square, becomes the quantity x plus 1 squared. The y's are now the perfect square, y minus 3 squared. And 3 plus 1 plus 9 is a total of 13 on the other side. So it looked a little intimidating at first with those coefficients in front of x and y, but just quickly dividing those out gets you now something in standard form with the center at -1, 3, and a radius of the square root of 13. Okay, so a little quick bit of a recap there of how do we complete the square. In number 2, there's a question like this on the homework. Write the equation of a circle whose center is at -4, 5, and it's tangent to the y-axis. I think a quick sketch helps you to visualize what's going on here. So -4, 5, that's going to be somewhere up here in quadrant 2. If we know the center, the only thing we need to know additionally to write the equation is what the radius is. If we're tangent to the y-axis, we mentioned that in the first lesson, that means it hits the y-axis once. And this distance from the center at -4, 5 to the y-axis is a distance of 4 units, right? Because we went 4 to the left to get over to this point. So if the radius is 4, we can quickly write the equation of saying x plus 4 squared plus y minus 5 squared equals 16. Keeping in mind that circle actually would not intersect the x-axis at all, because if the radius is only 4, remember that the height above was a radius of 5. So if I wanted to be tangent to the x-axis, it doesn't ask for this, but tangent to the x-axis would have been, meaning that we're only going to touch the x-axis in this one location, that radius just would have been 5. So same exact center, but now we would have 5 squared at the end, which is 25. So we can quickly kind of talk about both of those things without having to do too much additional work. And in this question, it says, what do the following graphs look like? There was a question on the homework that I said we're going to talk about it in today's notes, because if you look at part A, it looks like this is a circle whose center is at 9, -8, and whose radius is, well, if I take the square root of 0, that's 0. Doesn't sound like a very exciting circle to me if it has a radius of 0. So in fact, this is not a circle at all. Melody, what you doing over there?
I'm sounding out.
You're sounding out stuff? Okay. So I love that you're sounding out. Can you do it a little bit more quietly, though? Can you sound it out in your head, maybe?
I can't. I need to, talk.
You need to talk? Okay. So my students really want to learn about circles in this video. So we just have to do a little quieter. Maybe you could go do it at your desk if you want to sound it out.
No.
Okay. Well, if it's too loud, I'm going to have to kick you out. Sorry.
Kick me out?
Yeah, we're going to kick you out. Okay. The joys of distance learning from home, guys, right? Okay. In the second one, we have what, again, appears to look like a circle right off the bat. It would have a center at -2, 6, and a radius of the square root of -12. I mean, square root of -12, we haven't done square root of negatives in a while, but isn't this something that has an imaginary component to it? The square root of a negative wouldn't be a real number at all. So since this equals a negative number on the other side, this is actually, it's not anything. There are no points that define this equation. I can't plug in anything for x or y and get that the sum of those two squared numbers would be -12, right? Squaring a number makes it positive, adding two positives. No way we're ever going to get -12. So this is actually not an equation of anything. It looks like a circle in disguise. If it equals 0, it's a point. Equals a negative, it's nothing. If it equals anything positive, whether it's a perfect square or not, that would be something we could say is defined by a circle then. Okay, so just a quick thought. If you complete the square and in the end you get a negative on the other side, it actually from the start was not a circle. It's not an equation that represents any set of points that we can graph in a real coordinate plane. That type of concept will come up on tonight's homework. So I'll reference that when we get to it. If you turn to the next page, we have some questions where we're going to work backwards. And there's 2 questions like this in the notes today. Write the equation of a circle that passes through these points. 1, -2, 5, 4, and then 10, 5. So the idea behind this is that we can actually write, if we know 3 points on the outside of a circle, we don't know the center at all, but we can use a process that would allow us to find the equation of the circle, given that we know that it passes through these 3 points. What we're going to have to do is we're going to have to rely on, for this one, the general form equation of a circle. And the general form equation is basically what it looks like when it's not in completed square form. So it's x squared plus y squared. I'm going to let the coefficient of the x term be d, the coefficient of the y term be e, and the constant I'm going to call f. If you set that equal to 0, this is what the general form looks like for a circle. And this is a form that you'll have to be familiar with. Because if I said, hey, here are these 3 points on the outside of a circle, what you're going to do is you're going to plug each of them into the general form for x and y. So wherever you see x, wherever you see y, plug in those coordinates. And then we're going to get a system of equations that, since we have 3 points, we'll have 3 equations. And what do you know? 3 unknown variables. We need to figure out what are the values for d, e, and f. Okay, so let's start with the point 1, -2. That would be 1 squared plus -2 squared. When I plug in the 1 for x here next to d, I'm just going to put the 1 as a coefficient out front. So that's going to be plus 1d. If I plug in -2 for y, it's going to be minus 2e plus f equals 0. The only thing I want to do with that information is I want to rearrange this such that whatever this constant is out front, we kind of push that over to the other side. Okay, so that we have all of our equations set up the same way. So this was going to be the equation d minus 2e plus f equals, this is going to be 1 plus 4, which is a total of 5. When you move the 5 to this side with the 0, it's going to be a -5 on that side. So just be careful with that step. Let me show you what it looks like for the next point, 5, 4. So for the point 5, 4 would be 5 squared plus 4 squared plus 5d plus 4e plus f equals 0. All right, so again, let's just kind of rearrange this so that we get the constant on the other side. We're going to add those up in a second. 5d plus 4e plus f is equal to 25 and 16 is a total of 41. So if I subtract that over, it's a -41. This number on the other side will always turn out to be negative. Oh my gosh, that's a beautiful picture. I'm going to have to show them in just a second, Els.
Can I come in the video?
I'll let you know when it's time, okay?
Okay. Show the screen of it.
I will.
And then.
Okay. So now I'm plugging in that last point, 10, 5. 10 squared plus 5 squared plus 10d plus 5e plus f equals 0. So this last equation, these 2 numbers add up to a total of 125. So we're going to subtract that over to get this as our last equation. -125 over there. All right, so I want you to look at what I've written in red here. Everything in red are the 3 equations that we have to deal with. And again, we have 3 variables, d, e, and f. And man, I really wish we had a way to solve a system of equations that we have 3 equations and 3 unknowns in. But oh wait, that was primarily the entire focus of the last unit on matrices. So that's exactly what we're going to jump to. We're going to solve the system using matrices. And I'll tell you what we're going to do is I'm going to create an augmented matrix that has the coefficients of each of these equations. And the way we're going to write that down is the first row would be the coefficients of this equation, 1, -2, 1. I'm going to draw my wall and put a -5 on the other side. The next row would be 5, 4, 1, and -41. Last row, 10, 5, 1, -125. A couple quick notes about doing questions like this. Not only will this last column always be negative, because the numbers that I added over here are going to be positive, so I'm subtracting them over. But this third column in the matrix will always be ones, because we're never plugging in anything next to that F, so it's going to be 1, 1, 1 going down this column. A couple things that will always be consistent. So how am I going to solve this system? Oh boy, do I have to draw on the staircase and then get this into row echelon form, or even better, reduced row echelon form? Well, I mean, I guess we could do that, but get ready for this. I have not shown you this yet. The calculator can take this matrix and put it into reduced row echelon form for us. As a reminder, what does RREF look like? It's the ones on the steps, the zeros underneath, but it's also the zeros above the steps. And we don't usually do that when we do the process by hand, because it would take probably a little bit longer to put those zeros up there than it is to solve for Z, Y, and X like we traditionally have. But let me show you what we're going to do. We're going to go right to the calculator. And this is my expectation. You will not have to do this by hand in this unit. Okay. So I'm going to go to second matrix. I'm going to go over and edit matrix A, which I want to be a 3x4 matrix. Okay, so you'll know if it's the wrong size if you type in those dimensions and it doesn't look like the matrix we have. So let me go ahead and type in what we have here: 1, -2, 1, and -5 in the top row. 5, 4, 1, -41. 10, 5, 1, -125. Okay, I'm just going to double check that those numbers all look correct. It's looking pretty good to me. Okay, so here's what I'm going to do. Once I'm done editing a matrix, you always quit that screen, go back to the home screen. Now I'm going to hit second matrix. We're going to go over to the middle column called math. And we haven't really dealt with anything in this yet. But if you scroll over one to the right so that it says math at the top, I want to scroll up and look at what option B says, RREF. So hit enter for option B. One more time, go back to second matrix, hit enter for A. And if I do RREF of matrix A, it's going to solve that system for me. Wow, that was fast. You're probably sitting at home. Some of you are real mad at me right now, like, Mr. All, what have you been waiting for? Why have you waited so long to show us this? Well, I wanted to show you all the ways to solve a system, and without giving you some context as to how we would get the system to look like this in the end, we can't appreciate what the calculator can do for us so quickly. Not the answer you're looking for, but too bad. Okay. All right. So now that I have this, what do I know? I mean, look at that top row. It says that first number, which, remember, this is D now. It's not X, Y, and Z. It's D, E, and F. D is -18. E would be 6, and then F would be 25. So we can, after we did RREF, what is the result? That D is -18. E is 6, and then F is 25. So if we know the values of D, E, and F, we're going to go ahead and plug them back in to the original general form at the top, which said x squared plus y squared. The value of D is -18, so it's -18x plus 6y plus 25 equals 0. And you have to just pay attention to the directions. If it said leave your answer in general form, we're done. It didn't really specify anything at the top, but if it said convert to standard form, then you would have to complete the square. I'm not going to show you again how to do that. I think we'll actually do one more completing the square in today's lesson, but I'll show you really quick that if you do complete the square, you want to kind of test yourself out, you would get x minus 9 squared plus y plus 3 squared equals 65. And of course, the benefit to having it written in this form is that you automatically know the coordinates of the center and the length of the radius. Okay, so it's not too scary of a process. I know that it looks like a ton of work, but a lot of the work is just the algebra of plugging in the points to start, getting those equations set up such that then you just write down the matrix. And what should you be showing in terms of work? Pretty much exactly what I've written down here. Write down your 3x4 matrix, write down a little RREF out front, and then let the calculator do the work for you. So what I'm going to have you do is that the next question is pretty much an identical question to this one. Write the equation of a circle that passes through these points. go ahead and try this one. Write down what that general form is again. So the general form was x squared plus y squared plus dx plus ey plus f equals 0. Plug in those 3 points, see if you can get the 3 equations correct, write them in your augmented matrix, and then try that RREF. I'll show you what it looks like as an answer, but now's a really good time to hit pause, try it, and then come back to see if you get the correct answer. Okay. So here's what I have as my work here. If that's the general form, I plugged in the 3 points. These were the equations that I got over here. Here's what the augmented matrix looks like. Again, it's as simple as writing RREF up front. Hopefully, if you're able to do that correctly, if you don't remember or if you forgot how to do that step, just rewind the video to what I showed you how to do on the calculator. Here are the values for D, E, and F. So that's what it looks like in general form. If you put this in standard form by completing the square, you would go ahead and rearrange, complete the square, and then get this as your standard form answer. It actually has a pretty nice equation in the end because it's a center of 1, 1, and a radius of 5. So the radius came out to be a nice whole number value in this specific case. Okay, last thing I'm going to do with you is one more complete the square in case that's something that we still need a little bit more practice with. It's finding the center and radius of this circle right up here. It's actually pretty similar to what we started with at the start of today's lesson. If there's a coefficient out front, first thing you got to do is divide it out. So you got to divide both sides by 3 to get started in number 1 at the back. So it's going to be x squared plus y squared minus 2x plus 5/3 y equals 0. So it might look a little bit different from the start because we don't have that constant that we're going to have to move over to the other side. Not a huge deal. I do like having this rearranged though so that the x's are grouped together, the y's are grouped together, and kind of set the stage for completing the square. So the x is going to be pretty easy. It's going to be x squared minus 2x plus 1. Don't forget, even though there's nothing on the other side, just 0, you still have to add 1 to keep this balanced. For the y's, it's going to be y squared plus 5/3 y. All right, here's where we're not going to really love this, right? Because I have to take a fraction, divide it by 2, and then square it. So what's 5/3 divided by 2? Well, 5/3 divided by 2 is actually 5/6. Let's think of dividing by 2 as like multiplying by a half. So we get 5/6 squared, which sounds scary, but square the top, square the bottom to get 25 over 36. That's the number that completes the square for the y's. So add that to both sides. So for the x quantity, it's x minus 1 squared. For the y quantity, it's y plus something squared. So remember, how do I figure out what this number is? There's a couple different ways to do it. It's really whatever that b over 2 number was. Whatever this number is, which in this case should be 5/6. When I square that, I have to get back to this number, 25 over 36. So you can think of taking the square root of this. It's really whatever b over 2 is. A lot of ways that we can get that. All right, and then on the other side, I'm going to cross off the 1 and make it 36 over 36, just to make my life easier when I add those fractions together. So 36 and 25 is a total of 61 over 36. So this is a center for my circle at 1, -5/6. And the radius would be the square root of this last number. Radical 61 is not a nice number, but the square root of 36, we can express the bottom as a rational number of 6. So center and radius in that last one there. I know there's one more at the bottom. I'll show you what the answer is in case you're curious and you want to give it a shot. 183/4 looks scary. Oh, by the way, you're also going to have to divide that by 4. So it's going to turn into 183 over 16. Yikes. Here's what the answer is, though. If you want to take a peek at the work, try it out. Completely up to you. But in the end, here's my center and radius. Came out to be a really nice radius, surprisingly enough. Okay. So that's today's lesson. What I'm going to show you right now is the homework for tonight.